Konnichiwa. Hello, everyone. Thank you for coming. Today, we would like to talk about ways how to decrease the ATM fraud. I am Kochetova Olga, and he is my colleague Alexey Osipov. We are from Kaspersky Lab. You might be familiar with Kaspersky Lab as an antivirus company, but we also provide a huge amount of security services for various organizations. Usually banks call us when some bad guys came to them and make their ATM empty. First of all, let me give you several words about ATM in general for your understanding. You might find various kinds of ATMs. For example, standalone ATMs, through-the-wall ATMs. It might be cash out, cash in, or recycler module, but it's not so different because all ATMs just a Lego. Big vendor just put various hardware units such as dispenser, pin pad, and so on, produced by various manufacturers, and put it together into the box and called it ATMs, brand, blah, blah, blah. The top box of ATMs called service zone or cabinet. There are PC, a card reader, pin pad, and so on. The bottom box is a safe, which contains a device for cash. All hardware units, all devices connected to PC through serial or USB ports. What about software? Almost all ATMs around the world run on Windows and usually on Windows XP, despite the fact that Microsoft stopped to support this operating system more than 2 years ago. There are also main ATM applications which provide graphic user interface and device control. There are also some software for security, such as antivirus, integrity control, and so on, and other software. Devices are unclear. There are some microcontrollers with real-time operating system. And there are different levels protecting cash and customers' data against criminals. Each of these parts can be just chained, creating multiple points of failure, or can be used together. The lower the level, the easier to conduct fraud. For example, if we try to attack ATM network, which should attack operating system, Windows application, etc. In Wonderland, all ATMs are secure, and let's see how. The lowest level is closest to money, which contained in the cassettes. In Wonderland, cassettes are themselves secure. No one can get money from the cassettes without special permission. They are not only physically secure, but also logically secure. If someone will try to eject money, it will be evident and very hard. Nonetheless, if someone will steal the cassettes, it will be easy to trace them. And if someone will try to open the cassettes, money will be destroyed. For example, on the slide, you can see money destroyed with hot glue. In extreme case, even if cassettes is open and money are not destroyed, bank can trace banknotes by different means. For example, by using sequential numbers. As you might understand, not only cash is the goal of criminals, they also hunt for card data. But in ideal situation, in ideal world, card data can be stolen. There is no static data to be copied. And as for dynamic data, it uses challenge response schema that protect against relay attacks, and so data can be stolen. But it was only in Wonderland and in ideal situation. Since bank card contains MAC-stripe, it can be intercepted, and the EMV is not a panacea. For example, when I checked in the hotel, MAC-stripe was used for payments, only MAC-stripe, despite card has the EMV chip. Even then, there is possible to online relay attack. And as for cassettes, dispenser somehow managed to eject money from them. And it is possible for attacker to get cash by using just screwdriver. And if money was stolen, it is hard to trace them because of many ways to launder them in the black market or in our everyday life. But let's up to level 1. It's a level of hardware units. Typical dispenser consists of 4 cache cassettes and 1 cassette for ejected nodes. Each cache cassette consists of 3,000 banknotes. So typical dispenser and typical ATM, for example, here in Japan, might contain up to 50 million yen. And also there are many sensors, LEDs, and mechanisms which withdraw money. Some of them inject money from the cassettes. Other ones presented money for customers, check size of banknotes, and so on. So dispenser's firmware should be very complex. A card reader used to read MACstripe and also used to communicate with chip to conduct financial transactions and to check biometric data regarding match-on-card technologies. This device also should communicate with other units, such as PIN pad for offline authentication and the biometric device for biometric data check. PIN code is used together with card data for client authentication. It is the most secure element because of different standards. For example, PCI, EMV, and other standards provide the bottom line that PIN pad should comply to. But not anyone knows that there are 2 modes of operations, secure and open. Secure is used for PIN code, and open mode is used for other inputs. Biometric authentication gains popularity because of increased security. There are different kinds of recognition, such as iris, fingerprints, and so on. Such features uniquely identify user, so it is considered if they are presented to ATM, such users are considered good. It should be noticed that biometric data can be revoked or changed. Only processing center can send commands to hardware units, and hardware units authenticate with processing center. But sometimes authentication guarantees integrity of commands. But data should be also protected with encryption. In ideal situation, this data is only needed in processing center. Because firmware controls hardware units, it should not be easy modifiable, but it was another lie. Only so-called sensitive commands are authenticated. For example, dispense, but not present if we speak about dispenser. Rumor has it that PIN pad encrypted all data that comes from it, but it encrypts only PIN code, but not any data. And active man-in-the-middle attack can change one command with another. Another problem with encryption is forced for PIN code by PCI standards, but there are no such standards for card readers or biometric devices. For me, that's strange because you can easily change your PIN code, but you cannot change your iris or your fingers in case of compromise. Additionally, there are many systems which use biometric data, such as passports, visas, and so on. It means that if you lost your biometric data, you might lose your identity. Only PIN pad encrypt data in such a way that data can be decrypted only in processing center. Why it is not done for other hardware units, I don't know. And the last point is a firmware modification. Actually, it is not that hard to add some code to existing firmware to create some hidden backdoor. It will react on the sequence of the money dispense if you are speaking about dispenser.
Okay, we spoke about different levels on hardware security, on units on cache, but all these devices are interconnected, and they are all connected with pretty common interfaces, the very same that are used in every computer. It's USB buses, it's common interfaces for old ATM machines. It's so-called SDC connection or RS485. These are buses. There are also lines for connecting, like general peripheral input-output interfaces or UARTs. If device itself doesn't protect ATM machine or doesn't protect commands that are sent to it, maybe the communication lines should be protected. In ideal situation, yes, they are. Data in transit to the USB interfaces are encrypted, authenticated. Any tampering with the cables, and in many cases that we have seen in our everyday work, when ATM machines are compromised, such devices should not respond if USB cable was disconnected from host computer. But unfortunately, data is not encrypted. Only pin pad, as already mentioned by Olga, is protected with its own means. It's because of different standards, because of different manufacturers of such devices. We have a problem. This data can be intercepted. The devices can be controlled by other devices, not only by legitimate ones. Tampering with cables, well, it exists, but it exists only with third-party devices that can be provided by the vendor of ATM machine or provided by different third-party vendors that say, okay, you have a problem with so-called black box attack when attacker gets to ATM machine with their own devices, and we can solve this issue. But unfortunately, they are only selling the oxygen, they are selling nothing, and such devices only increase costs but not increase security. Not all of them, of course, but many of them are. And here's an example that Olga will show you.
Now we can see that attacker bypass first security measures. It's a physical security, who might buy the key from the internet, or it might be stolen. Attacker open the cabinet, disconnect the dispenser cable, and connected it to Raspberry Pi in this case, and it might be various devices, various microcontrollers, microcomputers, and so on. Now we can see that dispenser are so-called offline, but it still works. Then attacker sent commands to dispense money by using their smartphone, and we are waiting for money. It has happened because of no encryption and no authentication between dispenser and the ATM computer. It is very slow and old ATM, but finally our attacker have money. And of course, these commands might be repeat many times.
And it's not often the problem of the dispenser, not problem of the device, not problem of the software. In many cases, producers of all these devices may not be familiar with best practices with cryptography. Unfortunately, cryptography is very, very hard. And when someone say to you, okay, I use Diffie-Hellman for communication with the dispenser, you can say, okay, but what do you do with man-in-the-middle attacks? They say, okay, we have USB connections that is secure from man-in-the-middle, and you can do nothing. Unfortunately, bad guys are always watching for money, and with hardware units, they create different devices that can be connected in the middle of ATM machine and host, and such device can intercept all the data. And we have seen such issues in different incidents all around the world when such device was connected to interface of card reader and the data was intercepted. We often hear from banks that they have huge problems, for example, with skimmers. I don't know how it is often in your country, but in many cases, it's not only hardware that is connected outside of ATM machine. It also can be connected inside of it, and even not hardware, but software. On the slide, you can see different parts that are used by ATM to actually do something with ATM, with the devices, and to connect to the processing center. On the lowest level, we have service providers. They are so-called drivers or user mode programs that provide interfaces. Interface for application that is actually managing the transactions and the devices themselves. Such programs are created by vendors of the devices inside of ATM. For example, manufacturer of dispenser provide not only the device itself, but also the software to control it. Such devices, such programs have different capabilities to access the devices in them. As Olga mentioned, for the firmware of the dispenser, it is very complex because it should manage all the mechanics, all the servers or other devices in them. But unfortunately, the service providers are also complex, and they not only send in commands to device, for example, to dispense money, to get money, or to present them. They also have different features, service mode features, that enable control of every server, of every part of such device. For example, to open the shutter, to move the different parts of dispenser, of card reader. Such commands can also be used not to conduct fraud, but actually to break the device, to get it burned, because servers can easily be overheated and broken. As I mentioned, service providers provide interface to high applications. This interface is based on XFS. XFS stands for Extension for Financial Services, that was created by Microsoft in 1991. Often we hear that banks are already familiar with problems with this standard. They say, yes, we have the single point of failure. Yes, we're using it, but unfortunately, we can't do anything without it. It provides interoperability. It provides communication between Windows application and the devices. The devices announce the services, the application controls them. So-called Windows application are graphic user interfaces, and they are complex. They're not only communicating with the user, but they also communicate with processing center. They communicate with the devices. They communicate with XFS manager. There are different opportunities for service engineering, because ATM machine is quite a big beast, and it's not feasible to move such an ATM machine to servicing. The service engineer goes to ATM machine, starts special application, and diagnose the problem with ATM machine. Such service modes are enabled in general every ATM in every ATM vendor. They may be installed on this particular ATM just for easiness of servicing. They can be third party. For example, the service engineer should reboot the ATM machine, install special CD drive or USB stick, and start cut down version of Linux to actually manage this ATM machine. XFS and service providers should be considered as proxies, because the main idea that they are doing is sending transactional data to the devices. For example, when you enter your PIN code, it is transmitted from XFS Manager to Windows application. Then Windows application sends this data to the processing center, the very same data that it has received. And in ideal situation, such programs don't need to know anything about the data they're transmitting. Maybe they can add additional protection, for example, encryption or integrity, but no more than that. Windows application, in ideal world, has minimal interface because it just shows you pictures. It gets amount of money that you would like to withdraw, and that's it. For all service modes, there should be protection against with passwords or with hardware security tokens, and so on. And of course, the communication with the processing center should be additionally encrypted by the application itself, not by the devices or network that they are connected to. But as often happens, it's a lie. We have seen different malwares affecting all the parts of such system. For example, on the right-hand side, you can see Tupkin that is in the internet, in the news for many years. On the left-hand side, you can see other malwares that intercept data from the USB interfaces, from network communications, from USB devices. We don't have single point of failure, but rather we have multiple points of failure, because every such program, Windows application, XFS Manager, or service provider can issue commands to dispense money. And as already mentioned, bankers often say, XFS is a problem. Unfortunately, no. Problem is the trust zone that is created in ATM machines. For example, Kaspersky Lab found another virus that was affecting ATMs that don't know anything about XFS. It was intercepting commands that are used by service providers. And in this way, all the measures that are created, for example, in Windows application, it's not applicable. And no data, no forensic evidence was sent to different log systems, different programs that are there. It's just service provider who conducted all the activities. And Olga prepared the video representing such a virus.
So it's Win32 skimmers, which we researched with our grade department together several months ago. This very sophisticated malware, which works with service providers and activated only by special cards. Attacker should enter the code and enter the commands, number of commands, for example, withdraw money, and should enter the number of cassettes to withdraw money from. And it's again very easy to get money, and also might be repeat for many, many times until ATM became empty.
The problem is that when we speak about software means, we often see incidents. And when we see incidents, we often want to know how it actually happened. And with such malware, no data will be logged, no data will be transmitted. But even though we have connected, we have different problems on lower levels where we might have different countermeasures. We can have different security mechanisms. What about connecting to such a device from the outside? There are different mechanisms for protecting physical security of ATM machines. ATM machines may be considered in an ideal world as a steel and concrete sandwich that protects all the peripherals, all the data, all the cables inside of it. It's also tamper-proof, so no one can easily get access into such an ATM. It's tamper-evident because even if we try to protect it with just physical security, we also should know when it was compromised, when it happened. There are different alarm systems, and often we hear no one can get to the ATM machines inside of it without us knowing, and we will get there in 10 minutes. But unfortunately, 10 minutes, it's a very long time. As you can see on the previous videos, the successful attack took about 2 minutes. In 2 minutes, we can dispense about 40 banknotes a couple of times from any cassette and get away. When people with the guns, or security people will get to ATM machine, it may already lost many money. And if we conduct such activities on large scale, for example, on 100 ATMs or 1,000 ATMs, there's actually no security guys to mitigate such a problem. When we have connected to when we get to inside of ATM machine in so-called service box, as Olga said, we should get inside of operating system. But in many cases, it is just a platform to launch graphic user interface, to launch service providers, and that's it. It has password protections on different levels. It has role-based access for different customers, for user, for administrator, for the guys who just change paper inside of ATM machines. They also have some kind of access, logical access to operating system. And obviously, it has robust updates. If someone will find the problem inside of ATM machine, and it should be patched. Another point of entry is networking. ATMs doesn't do anything on their own. They should consult with the processing center to send your transactional data and to understand, do you have money to dispense? Do you have exceeded daily limits, and so on? It's also used for remote management because no one wants to go to ATM machines if you have 1,000 of them in different locations, even distant ones. And it sends also customization data because in many cases, there are different advertisements on ATM machines that create money for banks because someone are paying for such activities. But unfortunately, it's not. There are also different problems. In real world, top box of ATM is protected with a simple cover, plastic or very thin metal. Such cover can be easily drilled, and this picture taken from internet shows you that some guy got to the ATM machine with a drill, opened a hole in it, and connected to the cables that are inside of ATM. And as we mentioned in previous slides, such connection can be used by attacker to issue commands. And when we speak about buses, something that I forgot to mention, we can connect to any part of the cable to communicate with any device on such a bus. When we speak about network security, it's often considered that through-the-wall ATMs are secure, but on top left side of the slide, you can see an ATM machine that is through the wall with the exposed Ethernet cable outside of it. If attacker connects some device to it, he can actually manage to control such ATM machine. In many cases, service engineers are lazy, and they're exposing USB cables outside of ATM machine. You can actually connect any device to it, from keyboard to USB modem, to create another interface and to communicate with ATM machines. On the left bottom of the screen, you can see ATM machines that was protected by duct tape. And some service engineer don't want to introduce new lock to repair ATM machine. He just fixed it. And as for operating system, there are different problems with updates. Someone say that if it works, don't touch it. And for ATM machines, it's a rule of thumb. What we have seen that operating systems are not updated. And what we have seen in the last few months, many banks say, okay, we finally migrated from Windows XP to Windows 7. Guys, come on, we have Windows 10 already. And if you would have another 5 or 10 years to get to the Windows 10, actually you have a problem. You should have another plan, another update schedule or anything, because you have problems. Okay, we showed you that ATM machines can be affected on different levels. On different levels, they should be also protected. The last level is protection against infrastructure. Because when different banks came to us and say, we want to analyze our ATM machines for different security problems, different security measures, they say, we want to know whether our ATM machines can be affected by malware or affected by black box attacks. We say, okay, we can check for all the current state of art technologies or from future attacks. But we also say that there is a big infrastructure that is connected to the ATM machines. The banking system consists of different parts, for example, online banking, ATM machines, office computers, any other systems that are considered relevant, for example, SWIFT, and so on. Attackers that are compromising ATM machines or compromising banks have different targets. They may be affecting online banking, and so be it. But in many cases, they're affecting administrators. And actually, it's a thing that is provided in general pen tests or general social engineering awareness programs. When one machine is affected in the network, then privileges are escalated, and someone obtains administrator account. It may be not in 1 week, maybe not in 1 month, but unfortunately, when ATM administrator may be compromised, he can compromise management server. Such attack we have seen in the news. It's attack on the Taiwan ATM machines, when someone managed to access management server and install malware on all ATM machines. And in such a case, it's actually very easy for attacker to disable all security mechanisms, antiviruses, integrity controls, and so on the ATM machines. Install malware that will be executed just in memory without any touch of the disk of the computer. Then he will send other guys who don't have any knowledge of ATM machines to all ATMs of such a bank. And they will withdraw a huge amount of money in one time. But actually, there is also another problem. Because someone can access one ATM machine and compromise the network of ATM machines. Because what we see from PCI DSS requirements, there is also a requirement that all the data should be transmitted in a secure way. Secure way means for banks using VPN connections. But VPNs are not protecting the data. They're actually creating network And such network can be logically connecting all ATM machines inside of it. And if you protect the data that is transmitted from one ATM machine to the processing center, you should also consider protecting communication from one ATM machine to another ATM machines. And here's the video.
So here is our attacker who found the wrong settings ATM network. He also used a key which was buy from online or from an insider. Attacker opened the service zone, disconnected Ethernet cable from ATM, and connected it to Raspberry Pi again, but with other piece of codes. On this Raspberry Pi, it's software which emulate a real processing center. And now all ATMs in this network are under control of this attacker, of this piece of software, which is a rogue processing center, actually. Now other attackers came to ATM, and to all ATM of this network, and do something which looks like original transaction, but attackers may choose the number of cassettes to withdraw money from, and eject money as many as they want. And here is a jackpot of attackers. And actually, it might be used with any cards, with any pins. Now attacker came to ATMs again to leave no forensic evidence.
Okay, we've shown you that there are problems, that there are different security issues with ATM machines on so many levels. One can say that why vendors create such vulnerable ATM machines? Why applications have problems, have buffer overflows or different other security problems? And often we're asked for a silver bullet to protect ATM machines from all the attacks that are there. Unfortunately, there is no silver bullet. There is no software or hardware that will protect against all the attacks. But we can create something more secure if we will be a bit more open to different problems, because different banks suffer from the same problem, and they don't want to communicate with anyone to show that they are vulnerable. Yes, it's reputational risk. Yes, there are different issues with customers that will say, oh, you have problems, I will go to another bank. But unfortunately, what we see that the attacker attacks the low-hanging fruits of ATM security. For first couple of years, there was skimming. After that, there was logical attacks like black box, like rogue processing centers, and so on. All the videos that we showed you and all the issues in our slides are actually happening in real world. And unfortunately, banks don't have opportunity to fix lowest level of security, because such things are provided by ATM vendors. ATM vendors often do good thing, but in the wrong way. As already said, cryptography is hard. And we have seen patches for different devices in ATM machines that are implementing security, implementing encryption. But unfortunately, they're also vulnerable to different other attacks. And there is a problem with implementation, not with the algorithm, for example, and so on. Many people say that ATM security is for protecting one part of it. For example, protecting host machine, protecting cables, protecting network connection with VPNs, and so on. But actually, it's protecting the lowest link, and there are multiple points of failure inside of ATM. Actually, it's easier for a bank to understand that he has a problem. There are simple commands that can be used by not so knowledgeable people for ATM security. Go to your ATM machine, enter first two commands, and see what it will return. If it will return anything, you are screwed, because there are different software, there are different open ports that can be opened on ATM machines that are actually useless and not used for a long time. We have seen software that was created in 2009 that is installed on all ATM machines of one vendor that has a buffer overflow vulnerability. It wasn't used for many years, for 6 years, but unfortunately it has problems. Then you have Nmap. It's a general tool, and you should execute it from different parts of your network. In many cases that we have seen, banking systems doesn't have network segregation. And for example, Office user can ping ATM machine and actually send any command to it. And in many cases, there is a problem. You should execute it from outer networks, from inside networks, from VPN connections, and so on. There are no single feature that should be implemented. And of course, there is another point. You can install sniffers, and we already said some bank was suffering for 6 years with software skimmer inside his network without him knowing it. All the data, all the card data was stolen and transmitted to other people, and the data was, and credit cards were stolen. And in many cases, such attackers are very, very cautious. They're not using cards of the bank they are skimming. They're using cards that other users are inserting in such ATM machines. What we'd like to say, don't be the weak link inside of ATM machine. There are multiple points of failure, but there are multiple features that can be implemented in a sequential way to protect ATM machine from different problems. And don't forget that actually all the systems are made by the lowest bidder. And the lowest bidder not always creates what you want to, but creates what he can in such amount of money that you propose to him. As Olga said, one ATM machine consists of 50 million yens. And 50 million yens, it's only one ATM machine. We'd like to thank all the people who helped us with our presentation, with our research, who helped to reverse engineer the firmwares to fuzz the data and to understand why the ATM machines may be affected. If you have any questions, please ask, and thank you for your attention.
Oh, sorry, can I ask a question? Quick one.
Yeah.
Well, is there any security standards for ATM machines?
Can you repeat this question?
Oh, is there any sort of security standards that ATM machines need to comply with?
There are plenty of standards that ATM machines should comply to, but unfortunately, the standards may be also affected by different unknowledgeable people. And for example, when we speak about PIN pads, they have opportunity to encrypt data. Why such encryption not implemented for dispenser, we don't know. And there is no standard to encrypting the data to the dispenser. There is PCI PA for application on the ATM machine, but it doesn't protect the USB connections that are sending commands to application, not from outside of it.
Okay, so there is a lot of standards for each of the component, but there is no standards for whole ATM machine. Is that correct?
I think that this standard can't be done because all ATM machines are very different and there are different problems in them. yes, there is no single standard for everything.
Okay, thank you.
Thank you.